Hi learners! This video is part 2 of our introduction to geometry. If you have not watched part 1 yet, go ahead and watch it first. Click on the link below to be able to access part 1 of this lesson. In this video, we will continue developing the basic definitions of geometric terms and further check our understanding of the concepts by answering application problems. Problem-solving strategies will be incorporated in the hope that you will be able to develop the skills needed in solving problems in math and in real life. If your lesson is on developing definition of geometric terms, or if you have an assignment on this topic, or if you're preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Let us start by recalling the different geometric terms and their corresponding visual representations by jumping into this very first problem. Here's the problem. Refer to the diagram below. All geometric figures in the diagram are in one plane. So a diagram is given. Which terms are demonstrated in the diagram? A. Ray. B. Line. C. Point. D. Circle. E. Angle. F. Skew lines. G. Line segment. H. Perpendicular lines. I. Parallel lines. Okay, so we start by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? We are to determine which terms are in the given diagram. What do we need to be able to answer this correctly? First, we should know the descriptions or definitions of the terms. And second, we must know their visual representations. All of this are in part 1 of this lesson. So, we will look at this option, recall the description or definition, and visualize its representation. Then we will look for it in the diagram. You must remember that all the figures in the diagram are in one plane. That is given in the problem. Let us begin with option A, ray. Recall that a ray has one terminating end and the other end is extending infinitely. With that definition, can we now visualize its representation? Okay, let us look at the diagram and find out if it is here. Yes, it is here. There you are. I'm sure you can identify another ray in the diagram. We move on to option B, line. Recall again the description of a line and how it is visually represented. Is there a line here? You are correct. We have a lot. This is just one of the several that is here in the diagram. Let us go to option C, point. Do you see this in the diagram? We have several here, right? This is just one of the many. Next option, D, circle. Do we have a circle here? Of course, we have a circle here. Next option, E, angle. Remember that an angle has two sides and a vertex. Do we have this here? Let's find out. Oh, here it is. Next option, F, skew lines. Do you remember our definition of skew lines? Skew lines are lines that are in more than one plane. It says here in the problem that all the figures in the diagram are in one plane. So there's no skew lines here, right? Okay, next option G, line segment. Remember that a line segment has endpoints. Let us check our diagram. Do we have a line segment here? Yes, we have several. Here is one of the line segments. I'm sure you will be able to locate other line segments in the diagram. Next option, H, perpendicular lines. Remember that perpendicular lines are two lines forming a right angle at their point of intersection. Do we have them here? Yes, we have perpendicular lines. I am very positive that you can find another pair. Next option, I, parallel lines. Do we have this in the diagram? Remember that parallel lines do not intersect. The 90-degree angle formed between line A and line R and the 90-degree angle formed between line H and line R guarantee that line A and line H never intersect. So yes, we have parallel lines. There you are, learners. That was quite easy, right? So what are our answers? All terms except skew lines are demonstrated in the diagram. Okay, let us have this for our next problem. Here is the problem. Which geometric figures have measurable quantities? A, ray, B, line, C, angle, D, point, E, line segment. As usual, we must read the problem and read it several times when needed. What are we looking for here, learners? Okay, so we are asked which geometric figures have measurable quantities. In other words, we are to determine which figure or figures can be measured. Again, to answer this question, we need to recall their descriptions or definitions. We had an extensive discussion of this in part 1 of our video. Let's go. We will look at its option. Let us begin by examining option A, ray. How did we define a ray in part 1 of this lesson? Okay, so a ray is a set of points on a line that has one terminating end and the other end is extending infinitely. As shown in the figure, there is a terminating end, but the other end is infinitely long. It is going on forever. So can we measure it? You are correct. We can't measure it. Let us go to option B, line. What do you think, learners? Is this measurable? You are correct. We cannot measure a line considering that it goes on forever on both directions. Let us go to option C, angle. Remember that we defined an angle in part 1 as the radial distance between two rays or sides. So our angles has boundaries. It's two sides. Therefore, it is measurable, right? A protractor is used to measure an angle. Let us go to option D, point. What do you think, learners? Can we measure a point? You are right. A point is described as a location. So it is dimensionless. It is not measurable. Let us go to option E, line segment. What do you think, learners? How did we define a line segment in part 1 of this lesson? Okay, so a line segment is a part of the line bounded by two endpoints and contains every point on the line that is between its endpoints. There you are, learners. A line segment has endpoints. Therefore, we can measure it, right? Your pencil, an example of a line segment in real life, can be measured. Okay, learners, what are our answers here? There you are. C, angle, and E, line segment, are the geometric figures that have measurable quantities. Let us do the next problem. Here's the problem. The figure below shows line F, M, and H intersecting to form angles 1, 2, 3, 4, 5, and 6. The three lines are coplanar, meaning they are lying in the same plane. A figure is given. Based on the figure, which statement would provide enough information to conclude that line H is perpendicular to line N? A. The measure of angle 2 is 90 degrees. B. The measure of angle 3 is 90 degrees. C. The measure of angle 1 is 90 degrees. D. The measure of angle 6 is equal to the measure of angle 3. E. The measure of angle 5 plus the measure of angle 4 is equal to 90 degrees. F. The measure of angle 3 plus the measure of angle 2 is 90 degrees. Again, we must read the problem and may read it several times when needed to determine what we are looking for, what information are given, and to find out how the given information will help find what we are looking for. So, what are we looking for here, learners? You are correct. We are to determine which statement or statements would provide enough information to conclude that line H is perpendicular to line N. By the way, learners, when are lines perpendicular again? Great! Two lines are perpendicular when they form 90-degree angle or a right angle where they intersect. We have to remember that if one angle is right, the other three angles are also right angles. Let us add another line to the figure. What do you see now, learners? Okay, so two smaller angles, angle A and angle B, are created. Can you tell us the sum of the measure of angle A and angle B? You are right. The sum is 90 degrees. Before adding another line, the angle's measure was 90 degrees. When the 90-degree angle was divided into two parts, the sum of the two parts must be 90 degrees. We write it as, and we read it as the measure of angle A plus the measure of angle B equals 90 degrees. Okay, I think we can now go back to our problem. Let us look at the figure on our problem. Where are line H and line N? Okay, here they are. For these lines to be perpendicular, the angles at the point of intersection must all be 90 degrees. So we will put boxes to indicate the measure of 90 degrees. With the modification we did to the figure, we are now ready to answer the problem. We will analyze the statement and check it with the figure to determine if the statement provides enough information to conclude that line H is perpendicular to line N. Let's go. We'll start with option A. The measure of angle 2 is equal to 90 degrees. Let us look at the figure. Where is angle 2? Is the measure of angle 2 equals 90 degrees? No, it is not. The figure indicates a measure of less than 90 degrees. So the statement would not provide enough information to conclude that line H is perpendicular to line N. Did you get it, learners? Let us go to option B. The measure of angle 3 is equal to 90 degrees. Again, let us look at our drawing. Is angle 3 equal to 90 degrees? No, the angle is not equal to 90 degrees. It is less than 90 degrees as shown in the figure. So the statement would not provide enough information to conclude that line H is perpendicular to line N. Let's go to option C. The measure of angle 1 is equal to 90 degrees. Where's angle 1 in the figure? Is angle 1 equal to 90 degrees? Yes, angle 1 is 90 degrees. Since angle 1 is 90 degrees, and it is an angle formed at the intersection of line H and line N, This statement would provide enough information to conclude that line H is perpendicular to line N. Okay, let's go to option D. The measure of angle 6 is equal to the measure of angle 3. Where are angle 6 and angle 3 in the figure? Would this statement provide enough information to conclude that line H is perpendicular to line N? No, the statement would not provide information to conclude that line H is perpendicular to line N. Here's why. First, the measure of angle 6 or the measure of angle 3 is not 90 degrees. Furthermore, they are not formed at the intersection of line H and line N. Let us go to option E. The measure of angle 5 plus the measure of angle 4 is equal to 90 degrees. Where are angle 5 and angle 4 in the figure? Oh, the sum of the two angles is more than 90 degrees. So no, the statement would not provide the information to conclude that line H is perpendicular to line N. Let's go to option F. The measure of angle 3 plus the measure of angle 2 equals 90 degrees. Where are these angles in the figure? Okay, is the sum of the two angles equal to 90 degrees? Yes, the sum of the two angles is equal to 90 degrees. And these angles are the angles at the intersection of line H and line N. Therefore, this statement would provide enough information to conclude that line H is perpendicular to line N. Okay, so what are the answers to the problem? So we have C. The measure of angle 1 is equal to 90 degrees. And F, the measure of angle 3 plus the measure of angle 2 is equal to 90 degrees. There you are, learners. We are done answering the problem. Okay, so let us look at this figure to prepare for problem 4. What does the figure represent? You are right. The figure represents the main compass directions, which are north, south, east, and west directions. We call this cardinal directions. Relative to north, the directions east, south, and west are 90-degree interval in the clockwise direction. This suggests that line NS, or north-south, and line EW, or east-west, are perpendicular, right? Okay, here is problem number 4. The figure below shows a portion of a city where the first street and the second street run east to west, Delta Avenue runs north to south, and the other two streets, 32nd Street and 33rd Street, are straight as shown and remain straight. A figure is given. Which statements must be true based on the given information? A. First Street and Second Street are parallel. B. 33rd Street and 32nd Street intersect at 90-degree angle. C. 2nd Street intersects both 32nd Street and 33rd Street. D. Delta Avenue and the First Street are perpendicular. E. If more of the map is shown, 32nd Street will not intersect Delta Avenue. Again, we must read the problem and may read it several times when needed to determine what we are looking for, what information are given, and to figure out how the given information will help find what we are looking for. What are we looking for here, learners? Okay, so we are to determine which statements must be true based on the given information. We're given here a portion of the map. So we will analyze the statement in its option and verify if the statement is true based on what is stated on the stem of the problem and what is shown in the figure. Let us start with option A. First street and second street are parallel. Are the two streets really parallel? Let us find out. What is stated on the problem about them? The problem states that the first street and the second street run east to west. Let us look at the figure. Okay, so the two lines are running east to west. Since both are running east to west, the vertical distance between them will always be the same. Hence, they will never intersect, a requirement for parallel lines. So yes, the statement is true. The first street and the second street are parallel. Let us analyze option B. 33rd Street and 32nd Street intersect at 90-degree angle. Where are these in the figure? The information that we have from the problem is that both are straight and remain straight. The figure shows that they are straight and that they intersect, but there's no sign or symbol, like a box, to indicate that the intersection creates a 90-degree angle. So, the statement is not correct. Let us analyze option C. 2nd Street intersects both 32nd Street and 33rd Street. Let us look at the figure. Okay, the statement is correct. The point of intersections are clearly seen on the map. Let us analyze option D. Delta Avenue and the 1st Street are perpendicular. The problem states that the 1st Street runs east to west and Delta Avenue runs north to south. Remember the cardinal directions we discussed earlier? Let us look at this in the figure. Okay, so they are perpendicular. Yes, the statement is true. Let us analyze option E. If more of the map is shown, 32nd Street will not intersect Delta Avenue. Let us find out by extending 32nd Street and see what will happen. Oh, 32nd Street intersects Delta Avenue. So the statement is false. So the answers to the problems are A. 1st Street and 2nd Street are parallel. C. 2nd Street intersects both 32nd Street and 33rd Street. And D. Delta Avenue and the 1st Street are perpendicular. There you are, learners. We're done answering the problem. That was easy, right? Okay, learners, let us summarize what we have learned in today's video. We have learned that when solving a problem, you must read it and may read it several times to know what you're looking for, what information are given, and to figure out how this information can help solve the problem. Second, identify the important keywords on the problem and make sure that you know their definitions or descriptions and their visual representations. Third, when no figure is given, create a visual representation of the situation. Make a sketch. Fourth, when a figure is given, make use of it and modify when needed. Put the information stated on the problem into the figure so you will be able to see the whole picture. Fifth, cardinal directions represent the main compass directions, which are north, south, east, and west directions. Relative to north, the directions east, south, and west are 90-degree intervals in the clockwise direction, suggesting that the line north-south and line east-west are perpendicular. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget will